Hi, today I'm going to talk about Local Redirect Policy, LRP. LRP is a feature that is supported by Cilium, that has been around for a few releases, and lets us implement a policy to redirect traffic locally, essentially keeping traffic coming from a pod to stay within the same node. So I guess what's the use case here? And Kubernetes, you often have your pods accessing a service, right? And the service is fronting a couple of backends, other backend pods that might be located in two different nodes. So you might have a situation like this where you have a pod trying to access a service, and again, the service is in front of pods that are in different nodes. So your traffic may or may not leave the pod. Which again, that's kind of part of the Kubernetes platform. And there might be situations where you want the traffic to stay local. And it's quite similar to the concept of topology-aware routing, where, again, you don't want the traffic to leave the zone. And, you want to minimize latency. And here is the same principle. You want the traffic to stay within the node and avoid sending traffic to when it's not needed. And the most popular use case for this feature would be alongside something called NodeLocal DNSCache. Now, the principle here is to say, my pods are going to make DNS requests, and what if we could just run a local DNS cache within the node and use something like local redirect policy to force that DNS traffic, to stay within the node. Again, that's just really about improving latency and influencing the traffic to stay within the node. Now, how does it work in practice? Let's take a look in the demo. All right, let's get started in the demo. So I've got my little lab environment, and I'm running version 1.16.0, release candidate .1, so the version just released before the 1.16.0 release, which is coming out very shortly. So my sim environment is healthy, and I'm running on a CAN cluster. I've got 3 nodes, and I've activated this feature, the local redirect policy. As you can see, it's set to true. I'm just running a local private lab, and we'll hopefully make it public in a few weeks' time. So I'm going to show you a couple of examples of this local redirect policy and configuration. And first, I'm going to deploy my environment. So I'm going to have a backend pod, and which is going to be my server, and I'm going to have a client. Right? And I'm going to show you how we can force the traffic from the client to the backend to stay local. So let's take a look. So I've got a backend pod, as you can see. It's got a label called app proxy, and we'll use that label later on. And I've pinned it to the CAN worker node. Again, that's going to be important later on. So we'll go ahead and deploy it. Just take a few seconds to be up and running. Here we go. And now take a look. We're going to look at my backend, at my client pod, and again, that client pod is going to access the backend that I've just shown you before. And we'll go ahead and deploy it. And again, it will be take a few seconds to be created and to pick up an IP address. There we go. Now, I'm going to create my local policy. First, I'm going to create a service, and that's how what I'm going to do is I'm going to force traffic which is bound to that service to go to my local backend. So I've got my service here, which is just a very basic service listening on port 80. I don't actually have any. It's not actually fronting any pods right now, as you will see. So let's go ahead and deploy it. It has received an IP address. It's a cluster IP service, just a local service, internal service. And if I look into the Cilium agent, if I look at the list of services within the agent, I can see that the service has been created. Again, there's no backend because there's no pod that would match that selector, right? Which is, again, that's fine. It's just for this demo. And now what I'm going to do is show you this actual local redirect policy. And here what we're doing is we're saying that for traffic which is bound to my service called my service in the default namespace, I'm going to redirect to this particular endpoint which has this label. And again, I showed you before that this pod has this label, right? This app proxy. So any traffic to the my service in my default namespace will be directed to my local endpoint with that particular label. So we're going to go ahead and deploy it. Here we go. And now I'm going to go on the Cilium agent, which is running on the kind worker node. And I'm going to just double check that Cilium service list again. And here you can see that we've updated the service from cluster IP to local redirect. So traffic to the service IP will be forwarded to 10.244.1.11. And again, if we look back at our pod here, this is the IP address of LRP dashboard, right? So it's almost like what we had in the networking world, like static routing or policy-based routing, more like it, where you just kind of almost like bypass the networking table because you know there is a better path. So we're just going to verify and run a command. We're just going to do again a curl, and what we can see is we have a successful connectivity, right, from our pod, which is again on the CAN worker, to the service IP, right, which is here, and over port 80. Right? So we've been able to kind of forward and redirect the traffic from my MediaBot pod into our backend pod, again using a local redirect policy. So that's just an example of doing of using a local redirect policy. In practical terms, like I said before, the most evident use case is using DNS. So let's have a look in the next task. So we're going to use local redirect policy to reduce the DNS latency within the cluster. And we're combining local redirect policy with something called NodeLocal DNSCache. And you can read more on the Kubernetes.io, but essentially the concept is about running a daemon set of local DNS agents. And daemon set means you're going to have one across, one pod across all nodes in your cluster. So what we can do here is essentially force all the DNS traffic from our pods to stay within the node, and the entries will be cached, and so there will be kind of less traffic and improve latency, and we can also upgrade to TCP as well. So you see some of the benefits here, but it's really about reducing the latency for your DNS queries and just keeping them local. So let's take a look in the demo. Again, we're going to use the same kind of client that I was using in the previous demo. What we're going to do first is we're going to deploy a daemon set of the local DNS agents. And there are a couple of other things that you can look at. Again, you can find more details on this page. But now I've got my daemon set of local DNS agents, and what I want to do is I want to force all the DNS traffic to stay local. Again, we're using Cilium Local Redirect Policy. Let's take a quick look at what they look like. NodeLocal piece. So what we're doing here is we are essentially saying we want all the traffic, this bound for the kubedns server, to stay local, and we'll send that traffic to endpoints with that particular label. So again, what I've done, the daemon set I've just deployed, and we'll have a quick look in here, and we can see that we got pods, we got a daemon set, I got 3 nodes, so I got one NodeLocal DNS agent running on each node, and that got the labels that we've identified here, so you can see it's listing on 53. So all DNS traffic will stay localized. So we're going to go and deploy it. Go. And now we're going to go and verify that traffic is indeed staying local. So I'm just going to collect the statistics from each DNS local agent, and I'm going to run some DNS queries, and I'm going to make sure that only the stats on the same on the DNS agent running on the same node as my client are increasing. So we're doing this. So my local DNS is 10.244.1.86, and my kind of remote DNS is 10.244.2.15. And here what you can see is I can run some DNS, check the metrics on my DNSCache. I can see at the very start, just got statistics are the same. You can see just one request count total. So I'm going to go on my pod, MediaBot, which is, if you recall, running on Kind Worker, which is on the same one as this particular DNSCache. So I'm running a few queries. I'm running some lookup to google.com, isovalent.com, Cilium.io. And when I look at the statistic, I see that they've only increased on the local DNS agent, right? The one running on the same node, right? So none of them will be sent onto a remote DNS agent. So again, that's just a way to improve latency for DNS traffic. That can be used also for other use cases, but this is probably the most popular for LRP. I hope you found this useful. If you have any questions, just give me a shout, and thank you very much for watching.